Good morning. Today we are writing linear equations in the third form, which is called standard form. The two forms that we've had already, this one here, which is called point slope, because we're dealing with a point xy and a slope m. We've seen this equation before. This is called slope intercept form, because we have a slope m and a y-intercept b. This last form is our new form. This is what we call standard form. So standard form doesn't tell you anything about the equation, like the slope or y-intercept or something like that. This is just a form where we have x and we have y on the same side of the equal sign. A, b, and c are all just numbers. So some number times x plus some number times y equals some number. A, b, and c are just different letters to represent they could be different numbers. So we are going to look at how to convert from either of these two and get it into standard form. So if you have point slope form, let's say we're given these 2 points, we could find our slope. So we could label our points xy first point, xy second point, and plug them into our slope formula. So if we do that, our slope would be y2 minus y1, or 1 minus 7, and then x2 minus x1, or 5 minus 4. That will give us negative 6 on the top, and 5 minus 4 is 1, or just a negative 6, which is exactly what our slope is. Now, the reason why we have 2 equations written in here is because they could have used the first point using 4 and 7, like this equation, or the second equation using 5 and 1. So they wrote out both. Now, once you have that written down, you could just solve this for y. So if I solve for y, I'm just going to do the bottom equation because there's space to write underneath it. If we distribute this, negative 6 times x is negative 6x. Negative times a negative makes a positive, and 6 times 5 is 30. And if we want to get y by itself, all I have to do is subtract 1. So I have y equals negative 6x plus 31, which is exactly what's written right here. So we can move from point slope to slope intercept pretty easily just by solving for y. And then to get into standard form, all we have to do is get the x on the same side as the y. So I'm going to move that over. To move it over, I have to add 6x. And now that would give me 6x plus y equals 31. If you want, you can put a 1 there for 1y. And that's exactly what's written right there. The only thing about standard form that you need to be aware of is that these are all whole numbers. They're not decimals and they're not fractions. So this would be the best form. If you have one with fractions, technically yes, that's okay, but we'd like them to be whole numbers. So let's go through a couple examples. Right here, these are already written in standard form. We want 2 equations that are equivalent or equal to this equation. So if you think about it, think back to 6th grade or 7th grade, the fraction 1/2. Isn't that the same as 5/10? Well, all we did was multiply this equation, or this fraction, by 5. So that would give us 5/10. If I had 100 over 200, and I divided by, let's say, 5, I would get 20 over 40. All of these are all representing 1/2, so it doesn't matter if you multiply or divide, it's still going to be 1/2. Same thing with an equation. If I multiply this whole equation by 2, I would have, let's just distribute it, 10x plus 20y equals 30. This is an equivalent equation. If we were to solve for y, you would really have the same equation. If you wanted to instead, we could, let's say, maybe divide by 5. So if we wanted to instead divide by 5, divide everything by 5, we would have 1x plus, and this would be 2y equals 3. If you wanted to take this equation now and multiply it by 100 and get 100x plus 200y equals 300. They're all equivalent equations. So on your homework you'll have a couple that says write two equations. I wrote three now. In standard form. You will just have to multiply or divide. I'm going to say, let's just multiply this one by 2. Negative 2x plus 4y equals negative 18. I just multiplied everything by 2. If I wanted to take this equation now and multiply it by 5, that's fine, because it's really multiplying the original equation by 2 and then 5, which is really just 10. You multiply. So I could do that. This would give me negative 10x plus 20y equals whatever 5 times negative 18 is. It's going to be negative 90. So there's two equations that are equivalent to the first. Now we want to write an equation in standard form. That's when x and y are on the same side of the equal sign, when we're given a point and a slope. So if I'm given a point and a slope, think about it. Which form would I want to use or start off in? We have a point and a slope. I'm probably going to start with point-slope form, which is y minus y1 equals our slope, x minus x1. So let's plug in what we know. We have y minus y1, which is a negative 1. That makes a positive. Our slope is 3. And then x minus x1, which is 4. Well, now I can just distribute. 3 times x is 3x. 3 times negative 4 is negative 12. And then subtract 1 to get y by itself here first. These are all negatives, so that's a negative 13. Now this is, we started in point-slope form, then we moved to slope-intercept form, and then we need to get to standard form. So if we keep going, we want x and y on the same side. I'm going to subtract 3x, and we have negative 3x plus y equals negative 13. This is the answer that we would be looking for. You could put a 1 there with the y if you want. Same thing over here. Let's plug in what we know. This is x and y. My equation's right here. I'm just going to plug it in. Y minus a negative 4, making a positive, equals our slope, which is 1/2. And then x minus a negative 15, making also again a positive. So let's distribute. 1/2 times x is 1/2 x. Half of 15, well I know half of 14 is 7, so half of 15 would be 7.5 or 7.5. And we want y by itself first, so I'm going to subtract 4. So I have y equals 1/2 x, and 7 minus 4 is 3, and we have the 0.5. But we want it in standard form with x and y on the same side. So I'm going to subtract the 1/2 x. And we have negative 1/2 x plus y equals 3.5. Now this is technically an okay answer. However, we want all of the numbers to be whole numbers. Back here, all a, b, and c, all the numbers we would like in whole numbers. So I can just take this, just like we did before, and multiply it by something to get rid of the fraction. Well, if I just multiply 2, that'll get rid of the half, because a half and a half would make 1. So 2 times negative 1/2 is negative 1x. 2 times y is 2y. And 2 times 3.5 would give us 7. This is the smallest or most basic answer. You could have multiplied by another number to get rid of the fraction as well, but this is the smallest one that we could multiply by. So either of these would be good. Let's try the same thing again here, but we're not given a slope. We need to find the slope first. So I'm going to find my slope. So my slope formula, y2 minus y1 over x2 minus x1. So my slope is negative 3 minus a negative 1, making a positive. And then 2 minus 3. So negative 3 plus 1 is negative 2. 2 minus 3 is negative 1. 2 negatives make a positive, and 2 divided by 1 is 2. So I'm just going to pick one of my points to plug in to my equation, my point slope form, because I have a point and a slope now. So I'm going to have y minus y1. I'm just going to use this first point, which is negative 1, making a positive. Our slope is 2. And then x minus x1, which is 3. So when we solve this, let's distribute. 2 times x is 2x. 2 times negative 3 is negative 6. And then get y by itself, all we have to do is subtract 1. Y equals 2x minus 7. So that's in slope-intercept form, y equals mx plus b. But we want all the x's and the y's on the same side. So I'm just going to subtract 2x. We have a negative 2x. This is a positive y, so plus y equals negative 7. That is our answer. They're all whole numbers because this would be a 1. I would like for you to try this one on your own and then click play to see if you got it right. I'm going to find my slope first. y2 minus y1, or negative 5 minus 6. Then on the bottom, negative 12 minus 10. So that gives us a negative 11 on the top, on the numerator, and then negative 12 minus 10. They're all negative, so it's negative 22. 2 negatives make a positive, and 11 over 22, if we divide by 11, will give us 1/2 for our slope. So now let's use one of our 2 points. I'm going to just use the same equation here. Y minus, I'm just going to use my first point here, y1, which is 6, equals our slope, which is 1/2, and then x minus x1, which is 10. And then we're going to solve for y first. So distribute. 1/2 times x is just 1/2 x. 1/2 times negative 10 is negative 5. And then add 6 to get y by itself. We have y equals 1/2 x, and then negative 5 plus 6 is a positive 1. That is solved for y. I don't know why I circled that. We want to get x and y on the same side so that it is in standard form. So I'm going to subtract the 1/2 x over to the other side. So those are gone. I have negative 1/2 x plus y equals 1. And then this would be an acceptable answer, but for example on the MCA test they might have all of them with whole numbers instead of fractions. So we could take this whole thing and multiply by 2 to get rid of the fraction. So we'd have negative 1x, because 1/2 2 times would be 1, plus 2y equal to 2. That would also be an acceptable answer. Next, flip over to the next page. It says write equations of the horizontal and vertical lines that pass through the given point. So first, let's plot the point. Here's x and here's y. Same thing here. X is negative 3 to the left and y is negative 4. So they want the equation of the line that goes through this point. One horizontal and one vertical. So the horizontal line that would go right through here. This equation, remember when we wrote equations that are horizontal or vertical, we said it crosses the y-axis at a certain number. So this would be negative 1, negative 2, negative 3, negative 4. So this line would be the horizontal line. Y is crossing the y-axis at negative 4. That's that line. If we did the vertical line, the line that goes through this point is crossing the x-axis at negative 1, negative 2, negative 3. So it's really just looking at what's x and what's y to help determine what's the horizontal and vertical line that goes through that point. Same thing here, let's plot our point, x and y. X is 5 and y is negative 5 right here. So let's write the equations of the two lines that go through that point. First, the horizontal one, we're crossing the y-axis at -5, exactly what it says here, and -1, 2, 3, 4, we're crossing right there at -5. And we're crossing the x-axis at a +5. There you go. There are a couple questions like that on your homework. Next, let's just identify the form of the equation. This equation with x and y on the same side, this is the one that we learned today. This is called standard form. This one, where we have our slope in front of the parentheses and an x and a y, that's our point. This is what we call point slope form. And then last, when we have solve for y, this is, you could call it function form, or because we have a slope and a y-intercept, we call it slope-intercept form. There are a couple on your homework, I believe, where you have to match or write, identify the form of the equation. Next, write an equation from a graph. We have done this before. Step 1, find the slope. Rise over run, I'm really going down, -1, -2, -3, and over 1. That's the same as -3. We found our slope. Write an equation in point slope form, which is y minus y1 equals our slope, x minus x1. I'm going to use this point, 1, 1, as my x and my y. Just because they're smaller numbers, I prefer to use those. So y minus y1, which is 1, equal to our slope, which is -3. And then in parentheses, x minus x1, which is 1. So we wrote an equation in point slope form. Now rewrite it into slope-intercept form, or solving for y, just like we've been doing earlier. I'm going to distribute this. We have -3x and then a +3. This is y minus 1. And then add 1 on both sides. We have y equals -3x and then +4. And then last, write the equation in standard form. So when x and y are on the same side, all I have to do is move the x's over to be with the y's. We have 3x plus y equals 4. There's my answer. Alright, a couple more. This one, I believe, is very similar to one you have on your homework. It says you're making 24 pounds of your own potting soil mix of sphagnum peat moss and coarse sand. You buy the peat moss in bags that weigh approximately 2 pounds. The last time you made potting soil, you used 9 bags of the peat moss and 4 bags of coarse sand. Use this information to find the number of pounds in a bag of coarse sand. So we know that this 24 pounds, that's our whole total of the peat moss and the coarse sand. So I know that has to equal 24. And we only know that the peat moss, the first one, I'm going to say that's represented by x, and this is going to be represented by y, weigh approximately 2 pounds. So the peat moss is 2 pounds for every one of those, but we don't know how many pounds of, or how much the coarse sand weighs. But then they tell us some other information. You use 9 bags of the peat moss. So this x right here is really going to be a 9. And those are multiplied. And we have 4 bags of coarse sand. So this y is really going to be a 4. So we're going to just solve this to figure out what are we missing. How much does 1 bag of coarse sand weigh? How many pounds are in it? So 2 times 9 is 18. And then this, I'm just going to pick the letter A to represent this question mark. A times 4, or 4a, equals 24. And then I'm just going to solve it. We have 18 plus 4a equals 24. Subtract 18. We have 4a equal to 6. And then all I have to do is divide. Divide by 4. So A should equal 6 divided by 4, which is about 1.5. So each bag of peat moss weighs about 1.5 pounds. So the reason why I set this up like I did is because we knew the peat moss plus the sand equaled 24, and I knew how many of each we're getting, but I only knew the weight of one, so I needed to figure out the weight of the other. Now write an equation in standard form that models the possible combinations of peat moss and coarse sand you can use. Well, we kind of had that right here. We had 2 times x, which is the peat moss, plus the question mark, which we now know is 1.5 times the number of bags of y, equal to a total of 24. We just now know this information, so we can plug it in. And then it says list 3 possible combinations of whole bags of peat moss and coarse sand you can use to make the potting soil. Well, they already gave us one of them. We know that you could have 9 bags of peat moss and 4 bags of sand. That would give us a total weight right here. We could also graph this using our x and our y intercepts to find 3 different possible combinations. Easy way that I would say is try and figure out how many could you use of all of one or all of the other. This is basically finding our x-intercept and our y-intercept. You don't actually have to graph it. We're just going to plug in a 0 for one. Like if we don't use any of the sand and we use all peat moss, well, let's see how much we would have to get. So if I wanted to figure out how much peat moss am I going to have, I would plug in a 0 for y. So 2x plus 1.5 times 0 would just be 0 equals 24. So if I divide this by 2, x equals 12. So if I buy 12 bags of just the moss, the peat moss, I would have 0 bags of sand. So 12 moss and 0 sand. Or if I didn't have any sand, that would be gone here, and I would have 1.5 y equals 24, and divide by 1.5. So in my calculator, 24 divided by 1.5 gives me 16. So another combination here would be 16 of the sand and 0 of the peat moss. So this is one combination here, and the one they gave us would be 3. You could also guess and check to figure out what combinations you could plug in to get 24. Last one. Your class is going on a field trip, and you can travel in small and large vans. A small van holds 8 people, and a large van holds 12 people. Your class could fill 15 small vans and 2 large vans. Write an equation in standard form that models the possible combinations of small vans and large vans that your class could fill. So we know that I'm going to say the small vans are represented by X and the large vans are represented by Y. Oops, not L, Y. So we know the total. They don't tell us how many total people we have. We could figure that out in a minute. But right now, I know the small ones, X, hold 8 people. So 8 times X. Plus the large vans hold 12 people, and that's represented by Y. We have 8 people per number of vans and 12 people for this many number of vans. That will give us our total number of people that we could fit in both the vans. But we don't know that, so we're going to plug in. We know that we can fit in 15 small vans and 2 large vans. So we know 8 times, we got 15 of these, plus 12 passenger vans that we have 2 of them to give us our total. So 8 times 15 gives me 120, plus 12 times 2, which is 24, while 120 plus 24 is 144. So this is a total number of people. So instead of a question mark, we now know that we could fit 144 people. So the number of small vans plus the number of large vans would give us 144 people. So it says graph this equation. Similar to the last problem, you could solve for y and graph this. I'm just going to find my x-intercept and my y-intercept. So for my x-intercept, y is equal to 0. For my y-intercept, x is equal to 0. So for x-intercept first, it says 8x plus 12 times y, but if y is 0, anything times 0 is 0, equal to 144. So all we have to do is divide by 8. 144 divided by 8, my calculator would work. Here we go, 144 divided by 8 is 18. And if I find my y-intercept on this side, that would be when x is 0. So anything times 0 would be 0. So we have 12y equals 144. And divide by 12. Y equals 12. So I'm going to graph this. I'm just going to use the edges as my x and my y-intercept, or my x and y axes. So on my x-intercept, I'm going to have to get to 18, and on my y, I'm going to have to get to 12. So I can't go by 1s here. I'm going to maybe go by 3s, because these are both multiples of 3. 3, 6, 9, 12. You could also go by 2s. 2s would probably work as well. 2, 4, 6, 8, 10, 12. 18 would be right at the top. Yep. 18. But I'm going to go by 3s. 3, 6, 9, 12, 15, 18, 21. And plot them. So on my x-axis, 18, and on my y-axis, 12. And then draw your line. Be careful on this one that you draw a nice straight line. And then it says list several possible combinations. Well, we know they gave us the combination of 15 and 2. X would be 15 and y is 2, and that would be right here. That's the one that they gave us as the example. But we could also have lots of other combinations. These two endpoints are really easy to see. This would be when x, this one right here, when x is 0, y is up 12. So I'll be using just 12 passenger, or the, what's on our y-axis, the large vans. And these are small. Or this point right here would be only using small vans. So this would be when x is 18, y is 0, using only small vans. You could also come up with some other possibilities. Like right here, you could have 6 large vans and 9 small vans, or x, y, 9, 6. There's a variety. Here's several that we already listed. And here is your homework. Good luck!